today we are going to do some probability and fundamental counting principle. So let's get into it without any further delays. The first question that I have selected for us to do is a question based on contingency or two-way tables. So they've given us a survey conducted among 100 boys and 60 girls to determine how many of them watched watched TV during the period during which examinations were written. Their responses are shown in the partially completed table below. All right, so we've got male and female watched TV during exams or did not watch TV during exams. And the first thing that they want us to do is to calculate the values of A and B. Should I perhaps give you guys a chance to answer these questions on your own rather than me telling you what it is that you need to do? Do you want an opportunity to do that? Would that be better? Okay. All right. Letu says yes, please. And so does Mbalentle. No problem. So you guys try these and then I'll just work slowly behind you and do the answers. Okay. Okay, good. You guys are DMing your answers through. That's nice to see. Well done. Yes, Avayo. Yes, Mbalentle. That's good. That's correct so far. Yes, Mbali. Good, Lihlu. Yes, Lesedi. That's perfect. Good, Mbali. Good, Lesedi. That's excellent. You can go on to the next question. Good, iPhone 2. Good, Chloe. Yes, Tapelo. That's right. Nice. Lots of good answers coming through for 11.1. Well done. Yes, both of yours are correct, Tapelo. Good job. You can go on to 11.2. Let's see, Trish. Yes, your A and your B values are correct. Good, Trish. Nice. And I agree with your answer for 11.2 as well. Correct, Avio. That's the correct thinking. Good iPhone 2. That's correct for 11.2. iPhone 2, that's correct. Layer 2, yes, that's correct as well. Okay. Just make sure that you give a reason for your answer. 11.2, the answers I'm saying are correct. Just make sure that there's a reason. Okay, because it does say here, give a reason for our answer. We don't want to go and throw a mark away when we actually understand the question just because we didn't provide the reason that they want. Yes, Chloe, that is correct. That would be the answer for 11.3.1. Okay, not iPhone 2. This must be iPhone 1. So the other person using an iPhone, your answer for A and B are both correct. That's good. You can go on to 11.2 as well. Just gonna make this just a little bit smaller. Chloe, I didn't get that for 11.3.2, Chloe. My answer was different. Maybe I made a mistake. Just trying to see if no, my answer was different, but I could be wrong. I see my answer's different to layer 2's as well. Okay, maybe I've made a mistake with that. Okay, so we're all getting the same answer for 11.3.1, but when it comes to 11.3.2, we are getting different answers. Yes, iPhone 2, same answer. Good, Litlu, I agree. For 11.2, yes, Avio. For 11.3.1, same answer as you. That's good. So far, the only thing where our answers are different is for 11.3.2. Chad? Chloe, I didn't get that either. I don't know if I've made a mistake, but anyway, you guys can tell me what you think. Yes, Litlu, that's correct. So I'll just wait a couple of minutes and let you. Yes, Litlu, that's what I got. You've got the same answer as me for 11.3.2. So I'm just going to wait another minute or so. Okay, so Trish, I got the same answer for 11.3.1, but not 11.3.2. iPhone 2, I also got a different answer to you. Boycho, I think I got a different answer to you. Shame, Chloe. You keep sending me answers. I'm going to explain what I thought it should be now. Boycho, yes. 40, no, Avaya, I got a different answer, but I'll tell you. Okay, Jude, same answer for. Sorry, Chloe. You keep trying. I'm sorry. But then you can tell me if you think I'm wrong. Jude, 11.3.1 is cool. 11.3.2, I got a different answer. Boycho also got a different answer to you. Okay, so let's talk about 11.3.2 because we seem to be getting some different answers there. So just going back to the beginning, all of you said A was 20 and B was 128, which was perfect. Then as far as being male and did not watch TV during examinations, are they mutually exclusive? You should have said no, they're not mutually exclusive, because there are 20 boys or 20 males who did not watch TV in exams. Okay, so the events are not mutually exclusive. All right, so just make sure that you give your reason for the answer there. Then in 11.3.1, the probability that they watch TV in the period during which exams were written. So here what we would have done is we would have taken this B value and put it over 160. So the probability that TV was watched during the examinations was 128 out of 160, which most of you simplified to, sorry, this is 11.3.1. All right, but 11.3.2 seems to be where we have all kind of got a little bit of a different answer. So is not male. So if you're not male, you have to be female, right? There's nothing else that you can be. And you did not watch TV. So if you did not watch TV and you're not male, you have to be female and you have to be watching TV. So it has to be this. All right, so it's got to be 48 out of 160. Okay, which simplifies to 3 over 10. Zoom user, I'm sorry I'm calling you that. I would like to think not. They shouldn't penalize you for not simplifying it any further. Because really, at this point in time, they're testing to see whether you understand the question, not whether you can simplify a fraction. So I should think that they wouldn't, but just to be on the safe side, simplify your fractions, and then you've got nothing to worry about. But they really shouldn't. The marks will definitely be on this rather than on that. Okay. Yes, Lesedi, what's your question?
Hi, ma'am.
Hi there.
Ma'am, why did you use the 48 if the question says did not watch TV?
Okay, because
Aren't you supposed to use the 12?
No, because they want is not male and did not. Oh, I think I misinterpreted it incorrectly now. So is not male means has to be female, doesn't it? If you are not male, you have to be female. And did not watch TV. I think that's actually a little bit misleading. Okay, I see. So you guys are saying it should actually be 12 over 160, isn't it? Okay, all right. I understand. Okay, I think that's me. I misinterpreted how they meant that question. For me, it was a little bit, yeah, 3 out of 40. Okay, I think you guys are right, and I think I'm wrong. Sorry, I interpreted did not watch TV in the period as in the incorrect way. Okay, you guys are right and I'm wrong. Yeah, but the question is definitely a little bit vague. Okay, so I took it as for the opposite. If you're not watching TV, then they meant the opposite of that. Okay, so no, you're quite right. The 12 is correct. Okay, my apologies, guys. Well done. Okay, so yes, again, the marks would be over there. All right, thank you, Avaya. Okay. But well done all of you who actually ended up saying 3 out of 40, and I think it was most of you that actually did that. Okay, all right, awesome, good stuff. Well done, everybody. Can we move on to the next question? And Lesedi, well done for putting your hand up and saying that you don't agree with my answer. I don't always think that I'm right, so I really appreciate the fact that you guys also said, we think we're right here. Okay, good on you. Okay, let's move on and let's go and talk about independent events, and we're going to have a look at another question which then uses the fundamental counting principle. Okay, so in 11.1, they tell us that events A and B are independent. They tell us that the probability of A is 0.4 and the probability of B is 0.25. So in the first question, they want us to represent the given information on a Venn diagram and indicate on the Venn diagram the probabilities associated with each region. So again, I think what I'm going to do is I'm going to let you guys do 11.1.1 and 11.1.2 by yourselves. And again, you can DM Yolanda and I your answers. And hopefully I'm not a silly Billy and I don't make any mistakes in this one. Okay, cool, everybody. Let's do this. Okay, so it's a bit difficult. You can't obviously send me your Venn diagram, but once you've had a chance to draw it, you can always tell us that it's done and then send your answer for 11.1.2. Do you mean the what's inside the, Jude, I'm talking to you, sorry. Do you mean what's inside the Venn diagram that's not inside the events? Is that what you mean? Okay, so you have to minus what's inside your events from 1. Okay, so when you work with probabilities on a Venn diagram, your whole is 1. Okay, so minus the sum of the others from 1, minus the sum of the events from 1. Okay, I'm going to show you my Venn diagram now. And let's see what you guys come up with. I agree, Nolutondo, that's also what I got. Cool. Well done. That's exactly the right thing to work out. I agree, Nolutondo, that's what I got too. Yes. Yes, Avio, perfect. Okay, so Mbalentle, just be careful. Your probability can't be more than 1. Yes, Sehao, correct. No, Lutando, I got the same thing for B. What you've sent me. Yes, iPhone 2, that's correct. You have to minus it from 1. Litlu, I got a different answer to you for 11.2. Chad, I got the same answer as you. Nolatundo, I got a slightly different answer to you for that question. Yes, it is. It is iPhone 2. That for 11.1.2. Yes, that's what I got as well. Do you guys want me to draw the Venn diagram, or do you need a few more minutes? I can draw it, okay. Jude, I got a different answer. Please draw it, okay, that's fine. Okay, so let's just scooch over a little bit. So what's super important here is this first piece of information where they tell us that events A and B are independent. So when they tell us that events A and B are independent, it means that the area of intersection, so PA and B, or you can write it with the, not the union sign, that symbol over there is the probability of A times the probability of B. So remember, because what we want to do when we're drawing a Venn diagram is we want to work out, do events A and B overlap or don't they? Right. And if they do overlap, we have to start in the middle and work out what the value of that area of overlap is, and then work outwards. Okay. So Jude, I got a different answer for 11.1.2, and Avio, I also got a different answer. Not much, but a little bit different. So I'll explain to you how I did this. So the first thing I worked out was the probability of A and B by multiplying 0,4 with 0,25. Okay, so that gives us 0,1. So now when we draw our Venn diagram, we've got events A and B, and we know that this area of overlap over here has a value of 0,1. Like so. So there is no formula for mutually exclusive events. The way it works with mutually exclusive events is that PA and B would be equal to 0. So if events are mutually exclusive, PA and B will be equal to 0. Oh, sorry, Jude. No, that's not what I got, but I'm going to tell you now. Almost a bio. I'm going to show you what I got. Okay. Yes, iPhone 2, you are correct. That's perfect. Okay. All right. So now the whole of A is 0,4. So to work out the bit that is A only, you've got to say 0,4 minus that 0,1. And that's why some of us were getting an answer here of 0,3, which is correct. Remember, A means everything that is inside A. Okay, and then similarly, we've got to do the same with B. If the probability of getting B is 0,25, we have to subtract that 0,1. So this will be 0,25, like so. That's it, Avio. That's it. And now we've got to add these three numbers together, because if there's a difference between that and 1, that goes on the outside. Okay, and what we discover is that when we add 0.3, 0.1, and 0.25 together, we don't get 1, do we? We end up with 0.65. So now we've got to say 1 minus 0.65. Does that make sense? What did I write? Oh, yes, sorry. I just, I have got it as 1.5 on my Sorry, I wrote a 2 instead of a 1. That's correct. Okay, so now when we add these numbers together, the 0.3, the 0.1, and the 0.15, we end up with 0.55. Okay, so we would have to say 1 minus our 0.55, and then that would give us our 0.45, which goes into our sample space. So that 0.45 is neither A nor B. Is everybody happy with that? Cool. So they're definitely going to give us a mark on this. They're definitely going to give us a mark on this. I know this is only out of 3. Normally in Venn diagrams, they give you marks for things that you would have to calculate. Maybe there would be 1 mark on either 0.3 or the 0.15 in this case. All right, so that is, let me just put this here, that is 11.1.1. Now, in 11.1.2, they said A or not B. So A or not B means we cannot include anything that is inside B. So A or not B is this and that. That is A or not B. All right, no problem. So how did we get the 0.45 again? I'll just show you that on the side. So let me just scooch over and then I'll come back to 11.1. So what you would have done is you would have added 0.3, 0.1, and 0.15. That would have given you 0.55. Okay, and then you would have said 1 minus 0.55, and that's where the 0.45 comes from. Okay, because it's not A and it's also not B. Okay, so here for probability of A or not B, it's going to be 0.3 plus 0.45. That gives us 0.75. Okay. Are we all happy with that? That's out of 2 marks. So I'm sure that's where they would have allocated the marks in this case. Are we all good with that, everybody? Can we move on? Cool. All right. So now, again, I'm going to give you guys a chance to answer this question. All right. So in 11.2, Motors Incorporated manufacture cars with 5 different body styles, 4 different interior colors, and 6 different exterior colors as indicated in the table. The interior color of the car is not allowed to be the same as the exterior color. And Motor Incorporated wants to display one of each possible variation of its car in their showroom. The showroom has a floor space of 500 meters squared, and each car requires floor space of 5 meters squared. Is this display possible? Justify your answer with the necessary calculations. Okay, so I'm going to let you guys try that. Oh, okay. So Tsegofatso and Nolatondo, you're asking the same question. Let's just go back. If the or was replaced with and, how will it change it? Okay. So if they said probability A and not B, that's a good question. I don't think it actually would change anything in this regard because probability of A I think it would actually give us the same answer in this particular case if we said P, A, and not B. Right, but I mean, we all know that or and don't mean the same thing. But I think in this case, it would give us the same answer because P, A, and not B. So it has to be A. Oh, okay. You know how it would change? It would. Hang on a second. The answer wouldn't be the same. So if we said probability of A and not B, it has to be both at the same time. So it can't be A, can't be B, but it has to be A. So it would just be 0,3. That's how it would change. Okay. That's what you would have. P, A, and not B. Because and means it has to be both. So it has to be A and not B. So that means it would be A only. All right. Are we happy with that? Tegofatso and okay. Right. I'm going to answer. All right. So you want to talk about that a little bit more. Okay. So tegofatso, the word and means both at the same time. So in other words, like in the situation over here, when we were saying A and B, the word and specifically refers to this area over here. The word or, if I say A or B, it means everything that is inside A or everything that's inside B. So that means it would include this as well. So A or B means everything that is inside these circles. So the word or includes the and. Okay, the one that is both at the same time. Okay, so A or B is just, sorry, A and B is just the yellow. A or B, let's just get rid of that. A or B is what's in pink. Okay, and the pink includes the yellow as well. Does that make sense to you? There you go. You can take a picture of the question. That's why Tegofatso, if you think about this rule, I hope it is making sense to you, but that's why when we've got the probability of A or B, it's going to be the probability of A plus the probability of me minus the probability of A and B. Right? The reason that we have to minus is because when we work out the probability of A, it's everything that's inside the circle, including the area of overlap. When we say the probability of B, it's everything that is inside this circle. So we're including that area of overlap again. That's why we have to subtract 1,
Hello,
A
ma'am.
and B. Does that make sense to you, Tsegofatso?
Yes, ma'am.
Okay.
Ma'am, I wanted to ask the area of overlap for P, A, and the like, let's say the yellow part there for like the probability of A, it's 0.3 plus 0.1. And then
Correct.
for B, it would also be 0.15 plus 0.1.
Correct.
It will always, that middle part will equate to both.
It will belong in both. Absolutely. Absolutely,
Okay.
it belongs to both. So when they say the probability of A, they mean everything that's inside the circle of A. So that means A only and that which is A and B. Okay, and it's the same thing with the probability of B. It means that which is B only, but also that which is also A and B.
Okay. So, ma'am, can you also
Okay.
explain the fundamental meaning of independent? Like, what does it mean in the form
Okay,
of the...
no problem. So when we talk about events being independent, Let me give you an example. Okay, let's pretend we can always come back to this question just now. You can see there's my working out. Let's say, so you and I are going to share some sweets. Okay, and let's pretend that in this bag of sweets, there are 5 sweets and 3 are red and 2 are blue. Okay, so you put your hand into the bag, and you can either take out a red sweet or a blue sweet. Okay, so if I offer you a sweet, you have got a 3 in 5 chance of getting a red one and a 2 in 5 chance of getting a blue one. Now, when you put your hand in the bag and you take the sweet out, you're going to eat it, aren't you? You're not going to replace it. So that sweet
Yeah.
is now gone. So if I say to you, so you know what, you can have another sweet. That second time that you choose a sweet, these 2 events of you choosing a sweet and then you choosing a second sweet are going to be dependent, because the probability of you getting a red sweet or a blue sweet the next time around is affected by the fact that you've already eaten 1 red sweet, because now there are only 2 red sweets and there are 4 sweets in the bag.
Oh, I
Okay,
get it. I get it.
so these events, the second event is dependent on the first event. Okay, so that's what they mean by independent. Or look at it this way, like when your mom had you, she had a boy. But just because you were a boy didn't mean that if your mom had more children, that the next baby your mom has is going to be a boy or a girl. Okay, so when we have children, their gender is independent of any previous children's gender. Does that make sense to you?
Yes. So
Okay.
basically, three diagrams are based on like a dependent basis, and then Venn diagrams are based on like independent basis.
Not
Or how do
necessarily,
you see?
not necessarily. So you can use a tree diagram or a Venn diagram, or just a way of being able to draw the information. But both tree diagrams and Venn diagrams can be used for independent and dependent um, events.
Situation.
Yes,
Yeah.
situations. Yes, absolutely.
Oh, okay. But
Okay.
like for the curriculum that we learn, always going
Yes.
to be independent for Venn diagram and dependent on for tree diagrams if they have to ask them.
Yes, generally speaking, that's how we would draw them, 100%. I mean, it doesn't have to be like that, but most of the time that is what ends up happening. You're right. Yes.
Okay, thank you.
Okay, it's a pleasure. It's a pleasure. All right, guys. Shame, I know there's just a few last things that you want to clear up, and there's no problem with that. Okay, so let's try this question. Remember, we are trying to work out whether it's possible for Motors Incorporated to put on this display. All right, so the interior color of the car on the outside is not allowed to be the same. And they want to display as many of each possible variation in their showroom. Let's see what you guys do with this particular question. I'm going to give you a few minutes, and then we can come back and we can talk about how we would answer this. Okay, Jude, that's cool. Don't stress. I wouldn't use a tree diagram for this particular question. All right. What you should try and do here is you need to work out for a particular body style, what could the interior color be, how many different types of interior colors you could be, and then what the exterior color could be, right? So the way we set something like this out, if you want me to just show you, yeah, you'd be using counting principles for this. This is what I did, okay? So I worked with the interior colors, blue, gray, black, and red, okay? And I said, so that's what I'm putting over here. So this is my interior color. All right. Then my first block, this is my first thing over here, is the 5 different body styles. So this is my body styles. Nkanaisa, I will answer your question, I promise. And then I worked with my interior color, my body style. Four different interior colors, which we've got over there. And then this would be my exterior color. Okay, guys, sorry, I'm just got Nkanaisa also asking me a question at the same time. Hang on 1 minute. So Nkanaisa, the counting principle is going to be a difficult question, but if you think about it, like this would be something that's out of 6 marks. It's not a huge number of marks. It's the same when it comes to the application of calculus. It's not a massive amount of marks. So what you need is a strategy. Make sure in Nkanaisa that you go and answer all the questions you know how to do perfectly first, and then come and worry about these questions later on. All right. See, unfortunately, when it comes to questions on the counting principle, there's not really any rules you can learn. Like you can learn when you're supposed to use factorial notation and when you're supposed to use exponents. But apart from that, it's you have to rather use reason and logic in order to be able to get to the answer. All right, which is what makes it a lot more challenging. Right. But I mean, apart from doing, lots of past papers, there's not really much more that you can do beyond that. Okay. All right, let me just see what you guys are saying about this. And Nkanaisa, I hope that helps you. Okay, Ovaya. Yes, because the interior color and the exterior color cannot be the same. So if I've chosen blue as my interior color, then it means I can only have silver, white, green, red, or gold. Okay, so that's why I've got one less over here. All right. No problem. And then Nolatundo. I'm trying to work out what I was doing here as well earlier. I know, in Nkanaisa, there's so much pressure on you guys. Okay. So if it's blue on the inside, it can have one of 5 body styles, and it could be gold, red, green, white, or silver on the outside. Okay, so Mbalentli, this is what I'm explaining now. Okay, I'm going to explain how we did this. So based off of your interior color, All right. Your interior can be blue, gray, black, or red. So that's what I've got down the left-hand side over here. I could have 5 different body styles. So that's why I'm saying over here, I could have 5 body styles here, or 5 there, or 5 here, or 5 here. Right. Then as far as your exterior color is concerned, your exterior color cannot be the same as your interior color. So if your interior color is blue, you can only have silver, white, green, red, or gold. So that's 1, 2, 3, 4, 5. So that's why here, I mean, it doesn't make any difference whether you multiply by 1 or not. It's not going to change anything. Okay, so this would just be 5 by 5. Okay, in fact, we can ignore this. It's not going to make any difference. Does that make more sense to you, Mbalenhle? So you're trying to work out the number of ways in which this can happen. Let's just clear some space over here. Let's just clear some space. All right, that's fine. So the way that you have to do questions like this is you have to separate your different options from one another, all right, based off of working on one thing, right? So if you start with an interior color, your interior color can be blue, or it can be gray, or it can be black, or it can be red. All right. So the reason that I was multiplying by 1 is because there's only one interior color that it can be at a time. So this is the body styles over here. This is the exterior color, and this is your interior color. Okay, so body style is this. This is exterior color, and this is your interior color. So if it is gray, all right, there are 5 different body styles. How many exterior colors can it be? It could be silver or blue or white or green or red or gold. So it could be 6 colors on the outside, and it can only be 1 color on the inside, which is gray. Does that make sense to everybody?
Yes, ma'am.
Is it making sense? Okay. If it is black on the inside, okay, there are still 5 different body styles. If it's black on the inside, it can't be black on the inside, but there's no option for it being black on the inside. It can be silver, blue, white, green, red, or gold. So there are still 6 options for the exterior color, multiplied by 1 for the interior color, because the interior color has to be black. Okay, and then as far as red is concerned, there are 5 body styles. If it's red on the inside, it's not allowed to be red on the outside. So that's why there would be 5 options for the exterior color and 1 option for the interior color, which is red. Does that make more sense to everybody?
Ma'am, can I ask, how
Go
do we
for
know
it,
there are 5
Sekofatso.
body? How do we know
Pardon?
if there are 5? How do we know if there are 5 body styles?
It said so here in the question. Sorry, it's just off the screen at the moment. So over here, if you have a look, Tsegofatso, they told you there are 5 body styles over there.
Oh, I didn't see. Oh,
Okay, no,
thank
it's
you.
fine. It's difficult when you're going backwards and forwards and up and down and left and right, and then I get booted out and whatever. Okay. All right, so we are multiplying our options together. 5 body styles. If we've got a particular interior color, we have to exclude that color on the exterior if it exists. Okay, and now what we would need to do is add all of these up. So over here, we would get 25. There we would get 30. Here we would get 30. And here we would end up with 25 as well. So now we're going to add all of these together. Good. We get 110. Okay, so that is the number of cars that we would be able to fit into the space based off of these criteria or conditions that they've given us. We'd be able to get in 110 cars, right? But now they tell us that the showroom only has a floor space of 500 square meters, and each car requires a space of 5 square meters. So if we want to display 110 cars and each one takes 5 square meters, that means we would need 550 square meters of space. Right? But the showroom only has 500 square meters. So is it possible to display what they want to do? Do we have enough room? No, we don't. Quite right. We don't have enough room. Okay, because 550 is bigger than 500. Therefore, there is not enough room for the display. Come, you silly thing. Absolutely. Imagine applying this in real life. Okay, so this is a particularly difficult question. Right. Does it make a little bit more sense now? Are there any questions you want to ask me? Does it make sense? Okay. Tsegofatse, that is a good question. I think this was 2019 or 2018 that they asked this question. But it'll be on the DBE website. Yes, absolutely. In this case, you would layer to, because you're answering the question, is this display possible? Justify your answer with the necessary calculations. So yes, you absolutely would have to get a mark for saying, no, it's not possible. Okay. So here they would have given us a mark, I'm sure. Maybe we would get sort of 2 marks for that calculation like that. I think they would have given us 4 marks on that. They would have had to give us a mark on this, a mark on that. 1, 2, 3, 4, 5. Maybe a mark on that as well. Oh, there we go. Nolutando's found it. So it's the 2019 November paper. And Konaiza, let's see if I can answer your question. Let's say you got the wrong amount of cars, but still made the statement that there won't be enough space. Would you get marked wrong for the assumption? Yes, in Konaiza. So if you have done a calculation and like, let's say if they asked you whether events were independent or not, and you had done some calculations and you then worked out that the events were not independent. If your calculations are incorrect, but the statement that you have given is based off of those incorrect calculations, you're not going to get the marks. Okay. Yeah, no, unfortunately not, Amahle. Yeah, no, 2019 was hectic for those matrics. They really stepped up the standard in 2019. They've been a little bit more fair since then. There was quite a lot of backlash back in 2019 over that. Okay, so Voloshin, in paper 2, let's just answer this question just very quickly. You are looking at, just give me 1 second here. I have told them to send you guys the breakdowns for each section. Let's just get this open. So there's only 4 sections. So trig is 50 marks. Euclidean geometry is 40 marks. So that is 90 marks. So then it's 150 minus 90 gives us 60. Then you've probably got about 25 marks on stats. And then the other 35 marks will be on analytical geometry. Okay. Letu, that's a good question. They said they were going to send more stuff out to you guys. Yes. So that should be coming through to you any day now.